Thank you, sir. A very good morning to each of you. On behalf of Bangalore Chamber of Industry and Commerce, we welcome you all for the fourth in the webinar series jointly with Maxbyte Technologies, and today's subject being augmented reality for operational process efficiency and safety. We welcome Mr. N. Chandramouli, who is the past president of the chamber and who also chairs the Industry 4.0 Expert Committee. The committee is led by Mr. Jagannath, who is the CEO of M2 Next, a VFW company. And the chamber, I'm Roopa, Assistant Secretary General at BCIC, and I'm accompanied by Colonel Harish, who is the Secretary General of BCIC. Welcome, sir. And the chamber acknowledges the immense support from Maxbyte Technologies in jointly organizing this session. And we welcome Mr. Selvin, who is the Director Learning at Maxbyte Technologies. The chamber acknowledges the support of our annual sponsors who have contributed immensely to all the activities of the chamber. And before I hand it over to the chairman, I'd like to briefly introduce Mr. Selvin. And he, as the Director of Learning and Innovation, he leads engaging experiential and outcome-oriented training programs. He has been instrumental in guiding traditional manufacturing initiatives, enhancing operational excellence. In his role, Mr. Selvin carries on the importance of embracing digital transformation to stay competitive in the evolving industrial landscape. And that is Mr. Selvin. And now over to you, sir. Please take it over from here. Thank you.
Thank you, Roopa. Thank you, Colonel Harish.
Yes, sir.
First time we are meeting on the online, but I will come to office one of these days and meet you.
Sure, sir. Sure. Thank you. I look forward for that.
Thank you, Mr. Selvin, for doing this course for the benefit of the society, benefit of the industry. And 5 years back, when we started these programs in the middle of COVID, 2020, 20, 21, 22, 23, 24, almost 5 years plus. Augmented reality was more reality than even the real life. In fact, the acceleration of digital technologies and Industry 4.0 concepts, such as augmented reality, they took very strong traction and adoption during the COVID era, which is ironical. While there was a lot of lockdown and industry was struggling to keep both ends meet, the digital technologies took a center stage. It is not a paradox. The reason why digital technologies could gain traction during that period and now further accelerated post-COVID also is because they are able to connect people who are not physically meeting each other. The augmented reality and virtual reality are subjects where people get connected without being physically in the same place. A few illustrations. Mr. Selvin will show many illustrations, many use cases, many applications in multiple sectors. But a few illustrations, what really gained traction during COVID, I am personally aware of, is one example is a tractor industry. In the middle of the farm or the agricultural land, the tractor was under breakdown. One of the leaders of the tractor industry, they narrated to me like this. This is not a hypothetical case study. And he has thousands of tractors in the market. And they are all used by the farmers in the middle of agricultural land, in the wilderness. The only connection is not even a wired communication. It's not even a wireless communication, but it is an internet-enabled communication. And with the help of the internet-enabled communication, called the IoT, of which Selvin already conducted the classes already, coupled with augmented reality, which is what he's going to describe today, The combination of IoT and augmented reality made wonders in the remote maintenance of tractors. How does it happen? The experts to maintain or repair the tractor are in the headquarters of the tractor company. I'm not mentioning the company name for confidentiality's sake. But this company took the lead and several other companies followed suit. Actually, it's an Indian company who took the lead. Then the foreign companies followed suit. The designer at the headquarters, he knows all about the tractor engine, gearbox, etc., axle and all. The field, either as a farmer or ordinary maintenance engineer who has no knowledge of maintaining the tractor. See, unlike a car which goes on the road or a truck which is also on the road, they are called on-road vehicles. A two-wheeler, a four-wheeler or a truck are on-road vehicles, but a tractor is an off-road vehicle. An earth mover which goes in the mining industry is an off-road vehicle. The defense armored vehicles in the border of our international borders is an off-road vehicle. Imagine these off-road vehicle like a tractor or a earth mover or an armored vehicle are undergoing a breakdown. Or even for preventive maintenance, the expert is not available in the field. And especially the experts are missing during COVID. Even normal days, we don't have that kind of experts in the field. Even if you train people, they won't be as good as a person in the factory. The factory which produces these products, namely tractor, earth mover, or for that matter, even the armored vehicles, are well trained in assembling and disassembling the parts. They can also consult the R&D and designer to know which part had to be changed at what frequency, both for preventive maintenance and breakdown maintenance. I hope I'm audible. Gift Selvin, you can put your thumbs up if I'm audible.
Yes, sir.
Yes, sir.
Because there is some other voice I heard. I don't want to take away the thunder from Gift Selvin, but I just thought I will motivate the audience as more people are joining. It's 11:10, right? Before the course starts, I just want to touch upon the purpose of doing things is more important than doing the things. The why of it is more important than the what or the how or the where or the when and by whom. Among the 5W and 1H, ladies and gentlemen, the most important thing is why. If all of us get familiar with why we should do augmented reality coupled with IoT. Why did I say coupled with IoT? Without IoT, augmented reality is useless and vice versa. Now, my friends in the machine tool industry have adopted it very fast. Several machine tools break down across the country or even globally are maintained through an IoT and augmented reality from central factories which are producing those machine tools. There are real life case studies which we will do a factory tour one day. Roopa will arrange and Colonel Harish will arrange. In Bangalore itself, it's going on. So wherever there is a remote maintenance or remote engineering involved, it becomes extremely useful. Number one. Number two, when you are doing a factory assembly in a faraway location, a decentralized distributed manufacturing, as we call it. During COVID, it became very important. If you have to repair an aircraft, sometimes you may even have to assemble a part, such as jet engine. Even in factories, the remote factory may have less skill than the headquarters factory. In a multi-factory situation of the large group of companies like Tata, Mahindra, Toyota, etc., the main factory will have a lot of knowledge in assembling the product. The distant factories may not have the knowledge or skill to assemble the product. It will take a long time before they come to the same level as the main factory. Here again, IoT come augmented reality will play a major role. The third aspect, which is with which I will stop, is training the trainee and training the trainer. These days, even training companies have started using augmented reality. Before you put the people on training, on the job training on, let us say, a machine tool, you give them an augmented reality training. The muscle memory may not be achieved through augmented reality. So you really have to do physical training also. But the total duration of the physical training, let us say if it is 3 months, it comes down to just 1 month. The remaining 2 months can be condensed through augmented reality based training. In other words, ladies and gentlemen, there are 3 major applications of augmented realities. Selvin will talk much more about it. And he will also dwell on the technology of augmented reality and virtual reality. And the combination of both is called the mixed reality, which some applications he will talk about. Suffice to say, Industry 4.0, the 10 pillars. My personal opinion is augmented reality is a very important tool. I request all the academia who are listening today and the training institutions include augmented reality is one of the course curriculum and also IoT along with that. There is an interrelated technology called PLM 4.0. Unless and until the design and after sales service are talking to each other, the system is not effective in giving the quality feedback and service feedback. So PLM 4.0 is an inherent aspect of this. I hope Selvin will conduct courses on PLM 4.0 in the subsequent months. Kindly make a note, Mr. Selvin, along with Surendran and Ram Shankar, you can definitely do the course on PLM 4.0.
We'll plan, sir.
And then we will follow it up with a course on Lean 4.0, which is like a climax of our entire 6-month course. Thank you very much. It is 11:15. Sorry, I took away some time. Basically, to ensure that more people are joining to listen to Selvin, the detailed course. I may be logging out here and there, but I'll come back at 12 o'clock for the Q&A session. Thank you very much, Roopa. All the best for all of you. I hope recording has started. Yeah, Roopa?
Yes, sir. It started, sir.
And it is available on YouTube after this session. Thank you very much.
Thank you, sir.
Thank you, sir.
Now over to you, sir.
Thank you, Roopa. Thank you, Ensim, sir, for your great insights on the current industry perspectives with a lot of real-time examples. So once again, very good morning to you all. I'll share my screen. Let me share the sound also, yes. Yeah. So as the part of the continuous web series on the topic of smart and sustainable manufacturing solutions, today the 4th seminar, the topic is immersive technology for the operational efficiency and safety. So in this, we will be seeing various use cases, how the augmented reality is being used. Similarly, how the virtual reality can also be used in the industrial product life cycle. With various use cases you can able to see, so that at the end of the session you can able to understand that how these emerging immersive or extended reality technologies can help you life, to make it more easy. So in this session, the agenda will be about the concepts of our how they, what is mean by the augmented reality or virtual reality or mixed reality, and how the development process, application development process, and different various devices can be used in terms of AR or in terms of VR. What are all the differences and the developing process also, and what are all the current adoption trends. Then we'll be seeing how these technologies can be effectively used in various stages or phases of the product life cycle. Then finally, we can see the value proposition also. Yes. Yeah. So now we can see the immersive technology. We see that basically 2 areas like augmented reality and virtual reality. And what does it really mean? So what is augmented reality? Means you may hear or you may see many examples already. You may have some idea also. So now you can make it more clear also. So there is some difference between these two, augmented reality and virtual reality, and the applications are also slightly different. Okay, so coming to the augmented reality, what does it mean? Means, so this is basically the real world, how we see with our eyes. We can able to see the real world. In the real world, if we can able to augment or superimpose or add any digital content like pictures, text, audio or video or any 3D models or 3D animations, sounds, so anything. So if we could be able to superimpose it, then we can call it as augmented reality. That is the basic definition. So in the picture, you can able to see on the top of your table, if you can able to see any product, now you can able to see one house is there. So anything, 360-degree, you can keep that particular object on your floor or on your table. You can position it. Then you can see that is added with your real life through the device or through the camera of the device. You can able to see that is also included in your real world. See, so that is the augmented reality. So in the another example, you can able to see the how it helps for navigation also when we travel through car like that. So exactly it will guide you about the locations, about the street, about the building, about the shop. So whatever the information, if we could get exactly augmented or superimposed with the real world, then it is called augmented reality. So this is the basic thing. So that how it can be developed and what kind of devices it can be used, in what kind of applications it can be used are slightly different. We can see various use cases, so we can understand that. So coming to the next one, so virtual reality. So that also it is very known. You may know about that. The various headset also you might have used. You might have seen that. So basically, virtual reality is a kind of simulated experience or a completely simulated digital world. So you can immerse into the digital world, and you can able to see digitally a different whatever the created one. That may be a factory, that may be a forest, that may be an undersea world, whatever thing we can able to create it, and you can able to walk through in it and you can experience it, that new completely digital world. So in that, your eyes will be closed. So if you see the VR headset, the headset itself, you can able to see that that is completely closed. So you will be seeing some in front of your eyes, you will see some other digital display, so that you can able to see the 360-degree world all around you. That is totally different. You'll be detached with the real world. You'll be entering into the immersive world. So in this technology also, you can lot of use cases are there, especially the learning and training side. So very it will be very effective, this virtual reality. So that also we can see. So these devices are different. And coming to the word mixed reality means, so again, mixed reality is basically, it may be an augmented reality or a virtual reality. But in the virtual reality or augmented reality, suppose as a user, if you could or if you are allowed to interact with the digital content, then it is called mixed reality. Suppose in the virtual reality, even in any mall or any 3D or 5D small short movies, you might have experienced it. You might have gone through Jurassic Park like that, something like that, but you could experience it, but you cannot interact with that. Whereas whatever the application, if we develop, suppose if you can able to, if you play any virtual reality game, you can able to interact with that. You can be able to hit it, you can be able to lift it, you can be able to shoot it. So what with your bare hands or with your control devices, suppose if that will react, and you can you can play with that. So whatever you do, you can see the response in the digital world also. So then that VR is called mixed reality, VR based mixed reality. Similarly, in the augmented reality also, suppose if you can be able to only see the digital content on your space, in your real world, then it is a very only augmented reality. But if you can be able to interact with that, suppose if you can be able to touch the screen, or able to scroll it, or able to move it, are able to switch on to play something, to start the animation, any kind of physics, handling that objects, So many interactions we can able to give it in the augmented reality also. In that case, it is called mixed reality. So that is the difference. So hope that you can understand what is augmented reality, what is virtual reality, and what is the mixed reality means. So these three together called as an extended reality. So we call it as XR also. So these are all the normal, the terminology we used it. Okay. So coming to the augmented reality indeed. So coming to the augmented reality, the devices which are all can be mostly used is basically our smartphone. Any mobile phone can be used as an augmented reality device, or any tablet can be used. And the next is the realware kind of head-mounted tablet. So that is your hands are free. Suppose the person is working in a height or any in particular site itself. So he cannot hold any mobile phone or any tablet. At that time, he can use the realware. So realware in your one eye, you can able to see the tablet kind of thing. So with your voice, you can interact with that device, and you can able to see any drawing, any 3D model, any kind of information. So all things how you can physically handle your tablet, same thing in front of your eyes, you will get all the information to do your particular work. You will get all the information. So that is kind of head-mounted tablet. And the next one, what you are seeing is the mixed reality glass. That is a Microsoft HoloLens 2. Now it is known in many MR applications, and many upcoming MR devices also coming. So Microsoft HoloLens 2 is very popular for this application. So in this one also, your hands are free. So unlike the mobile or tablet, you don't need to operate with your hands. When you wear the headset, you can it's a kind of see-through glass, and you can see the real world. And also there is a projection capabilities there. So through that, you can able to see any digital content, augmented with the depth. So in front of your eyes. So whatever thing you want to see, whatever is in the application, you can able to see that, and you can able to interact that also. So these are all the three, devices can be used. And when you develop it, we need platform and we need SDKs. So the SDKs, normally certain SDKs are freely available, and certain SDKs we need to pay for the license. So the very popular SDKs means software development kit. So basically, to get the augmented experience, we need these SDKs. Like Viforia is a PT from PTC. Viforia have many SDKs, and AR Toolkit, and AR Core, and AR Kit, and MaxST, and Wikitude, and MR Toolkit. MRTK is a special, especially for the HoloLens, for mixed reality applications. MR Toolkit also can be used. So these are all in the perspective of developing or developer, perspective. You can understand that. Okay, so the main platform to be can be used to develop this kind of augmented reality application is the Unity 3D is very popular one. That is it's a kind of very powerful task platform 3D engine, and is very user friendly. Also, it is very easy for the beginners and very powerful enough for the expert. It is very flexible, and you can do any kind of applications like mobile application, desktop application, and web-based or browser-based application. Also, we can develop through the Unity 3D. And apart from that, with this, we can develop 2D games, 3D games, and the augmented reality application. And also, we can use the same Unity 3D for virtual reality application. And both interactive mixed reality applications can also be developed with the Unity 3D platform. And this is completely free for the students. So completely the entire software is free, so that anyone can easily learn and they can develop it. Yeah. And apart from that, the additional softwares needed for this kind of application development is for video editing, because inside these applications we may use a lot of pictures, a lot of videos, a lot of 3D models, 3D animations to make the live feel. We need to create the actual product as a 3D model with more realistic model. So for that, we may need additional this kind of tools or softwares also. For the video editing, we may need the Adobe effects and Adobe Premiere, and for pictures, the Photoshop and Adobe Illustrator and XD and Figma. These are all can be used for user interface development and user experience and visual graphics and everything. For audio effects, sound effects, and the Audacity can be used, and Pro Tools. All these kind of things can be used to prepare the 3D model to create the environment or factory environment or any kind of tools or machines. So we can use these kind of 3D softwares like AutoCAD or any 3D softwares, the 3D files can be used like SolidWorks, Unigraphics, anything. So we can convert that model as a neutral format and we can use it. So apart from AutoCAD, ZBrush, 3ds Max, SketchUp, Blender, so these are all can be used for to create more realistic model, like more rendering or texture and material and lighting. All these things can be applied that so that it looks like more real product like that. So normally we use the Visual Studio scripting for the development of this applications, and the C# coding is being used. And coming to the process, as like other software platforms, applications, so normally the requirement study should be done first, and the workflow and storyboard to be prepared, and UA and UX design to be done. Then it has to be reviewed with the customer or the user, and we have to get the approval. Then all the required 3D model preparations to be done, and rendering and texturing and material applying and lightings, light effects, all these things to be done in the software. Then the UI, user interface functionality to be done. Then we have to select the scanning views, that may be image or QR code scanning method, or that can be a model scanning method, or that can be a spatial scanning method. So based on the application or the requirement, the developer will choose the scanning view and then the target method. Then he will choose the SDKs accordingly. Then the scripting is to be done, all the functionality to be written like that. Then we have to select the platform also and the device also. So based on that, whether we are going to use it in the Android-based devices or iOS-based devices, so the output can be taken like that. So if it is Android, the APK format will be taken as output, or if it is iOS, the IPA format will be taken as output. And finally, that will be tested by the user and validated. Then everything is done. This application can be published in Play Store or App Store, or privately can be used only that can be installed in only specific number of engineers device alone. It need not be published in App Store or Play Store. Anyway, we can use it based on the confidentiality. We can use it. Coming to the virtual reality, the devices are different. So you can see some sample devices like Oculus and HTC Vive and Samsung Gear VR. So these are all some sample devices, and many models are available in the market now. But if you come to the specifications level, we can classify as three different types. Like basically, it is called a VR headset or head-mounted display. So the very simple one is like a small cardboard box like devices you might have seen. In that, you can use your own mobile phone as a powered device. You can insert that one. That will be in many YouTubes. You can see many VR-based applications available. So that will divide into two screens. So you can see in front of your eyes. So there is very low cost device. So we call it as a smartphone powered devices. So the next one is the tethered headset. So that is slightly different. The headset will have the displays, but there will not be any memory or any graphics support or streaming capability. So only you will have for both eyes, you will have different displays available. So you can use a mobile phone as a streaming device. So from the mobile phone, the data will stream to your headset. So there will be a wired connection will be there. So that is also a cost-effective one. So you can use mobile phone, then along with that head-mounted device. So the next one is a standalone device. Standalone device is completely kind of head-mounted computer like that. So that will have the OS will be there. That will have the memory space like 128 GB or 256 GB, and it will have a graphical support specifications are there. So it will have a Wi-Fi connection. You can do it. So it is completely standalone. You can wear it. Maybe you can connect with internet. You can through air also the streaming can be done, or you can keep the application inside your device also, and you can play that. So all these things are possible in the standalone devices. So coming to the platform, as I said, Unity 3D can be used to develop virtual reality applications also, and Unreal Engine is another popular platform to develop the virtual reality applications, especially for the on the high-end AAA games. The Unreal Engine being used, because the Unreal Engine, the output will be very, very realistic, very sophisticated one. But thing is, we need a more virtual, the visual graphic support is more needed. So there is a difference between Unity 3D and Unreal Engine. And another one from Amazon, the Lumberyard also, one of the platform is being used. So after these three, Unity is the mostly used one in AR and as well as VR. And coming to the SDK, here for the virtual reality also, the software development kits are different to develop, the interactive functionalities and VR experience. We need the SDKs. For Windows-based application, we will be using Steam VR. And for Oculus, we'll be using nowadays the Meta X are also released by Oculus. So that SDK can be used for Android and as well as Windows. So the development process slightly different. Here also we need to develop the strategy first, where we are going to use for any kind of training, any kind of a simulation experience. So all these things first we have to record it. Then based on the requirement, we have to do the analysis and storyboard. We have to write it. Then we have to prepare all the environment, the 3D assets. We have to create it. Then the virtual reality development with this SDKs to be done, all the functionality and scripting to be done. Then finally, it is to be tested, and we need to get the validation with the end user. Then it has to be released. Then further enhancements can be done with that. So basically, either AR or VR, to use the application, we need certain parameters very important. Otherwise, it is very difficult to use it. So we need the best realistic model for any applications. The content is very, very important. The visual content is very important, and the model quality is very important. And the size also optimized, very, very lightweight size. So the very optimized mesh mount is also needed. So you have to leverage that. The visual quality also important, and also the size also important, so that the loading time will be very less and very quickly it will load, and you will get there will not be any latency issue. So the user will feel very dynamic. So that is more important. Apart from that, the physics, the interaction, the various physics options are there. So we have to effectively use that. So for more experience for the user, and sound effects and visual effects should be given accordingly. The post processing also very, very important. So all these are the very important factor to enhance the experience. Okay, so now we are going to see some trends, how it is happening, how it is being adopted and used. So, I see that it keeps on emerging now, and in the gaming and entertainment world, it is it has a great impact, great disruptions there. Apart from that, gaming and entertainment, other industries, you can able to see that healthcare and medical devices, they are using very high level, and next is education, and next is workforce development or training segments, and next is manufacturing and automotive segment. So these are all the segments. Their the adoption is keeps on increasing as a top 3 or top 5. You can able to see that. Yeah. So another one trend, you can see that still the adoption or investment on these applications and devices are less only because the technologies keeps on coming, and new better resolution devices are coming, and low cost devices are coming. So still the adoption is growing, but still now we are in the low only. But the ROI is really going better. Now it is overall already using. The return on investment is really very nearly high ROI is there, and TCO also really good, very high level is there, and for the satisfaction also, so more than moderate is there.
What is TCO?
Total cost of ownership success. ROI is return on investment success.
Explain it to the audience.
Yeah. So for any application, we need the device, we need the software, software investment. So the total cost of ownership for the particular application. So like any software application, so this also we need separate devices needed, separate applications needed. So all these cost, and when we use it in our particular process, or where we want to enhance the experience or enhance the productivity. So the success after investing for the device and the application, really they can able to get the the cost of ownership is they can able to realize the benefits out of that. So earlier it was difficult because the cost is devices are more. Now the cost of the devices is coming down.
Thank you, Gift.
So, Okay, so one more strategy, the fact I would like to emphasize here, how VR is very effective for trainings. So we know that what is virtual reality, we know that it is really used for gaming and entertainment. But coming to the learning, so in the coming years, maybe in the coming decade, definitely the VR will be more used in the training area, or the workforce development area. So if we look at the learning pyramid, it is commonly available, the fact, it is a fact you can get from Google search. How our learning is happening is like through lecture, only 5% knowledge retention is there. And when we read it, 10%. When audio and visual is there, 20%. When we see the demonstration, it is 30%. When we interact with the group discussion, it is 50%. When you do hands-on, like when we practice it by doing it, it is 75% knowledge retention is be there. And when we teach to others, then it will be 90%. So this is a standard learning pyramid. When we use the virtual reality for learning, so we will be in the practice by doing, or the kind of, it is similarly to the hands-on experience. So the knowledge retention is 75%. So that is a major advantage when you use the virtual reality in trainings. And apart from that, when a person is engaged with the VR, he is completely engaged. So unlike a classroom session, is he cannot, no diversions will be there. So his eyes will be closed. So obviously he will play through gamification. He will learn it. So the engagement will be high. No distractions will be there. And when you compare with the classroom session, so suppose if we do any 6 to 8 hours classroom session, when we convert that as a training in the virtual reality, in 2 hours, he can able to complete it, 1 to 2 hours, the entire learning, because he will be more focused. He will be, fully engaged or immersive with that. So it is 4x faster than the usual classroom methods. And many statistics, like they're saying that, and I think in one company, so Walmart, right, that they have implemented this for the safety training, and they see that 43% of reduction in their workplace injuries, because the people who undergo these kind of trainings, they can able to remember for longer time. So that result is also really good. Okay, so now we are going to see many use cases in the product lifecycle domain, like marketing or design area, and manufacturing or operations segment, and after sale, like a services area. So we will see many use cases one by one. I will show that. So first, marketing, you see. So what kind of, because now we have seen AR is separate and the VR is separate, and which application, which technology is effective, which kind of devices is really more suitable for that particular experience. So we can see many use cases, so that you can able to understand that. So this is one of the simple use case, like how augmented reality can be used to enhance the buyer experience. So now we buy with pictures or 3D models, we can able to see before buying a product, something like that. So apart from that, so when we use the AR based catalog, they can able to see the model before they buy it. So this is one small example, just to demonstrate how the user can see AR based catalog before they buy it. So this is the kind of a water purifier or any water dispenser systems. So before he buy it, he can be able to. Yeah, there is just it is just a music, sir. So I reduced it. Okay. So here, unlike the PDF catalog or any web-based catalog, in the mobile itself, he can able to swap various model, and he can experience it. Then he can decide it which one he has to buy. So this is one small example. Like this, any big machineries also can be placed in the shop floor. You can see whether the size is okay, whether they can able to fit it, and its specifications, its operations, functions, everything. With the animation, we can do that. With many kind of interactive ways, we can the user can experience it. Then he can able to decide which model he can buy it. So this is one small example. So like this, even a big car or any earth mover also can be viewed in their own floor. They can 360 degree, they can watch it, and their operational animations also, they can see retracted position and everything. Then they can choose whether I can go for this model or not. So that kind of, this is a very simple application. The mobile or tablet itself, the user can easily, they can see all the your products. They can swap it. They can understand it, and you can tag any additional technical specifications like it itself will explain it, all its features like that. So then he can decide it. So this is called we call it as a pre-buying experience application. So next is a web-based application. So we have all our products in our website. This is also very simple application. So AI-based application. In the website, in our HTML web pages, normally we have pictures, and we can embed 3D files also. So that is also now it is possible. On top of that, we can give the AR experience also to all our customers. The customer who are all visiting our website, they don't need to install any additional application. So they can able to simply browse the browser, and if for a particular product, they can able to swap it, they can able to zoom it, zoom out. In the screen itself, they can able to see it. Then for AR experience, if we click one button, it will open the camera, and he can, this is a small example you can see. So now he is seeing in the 2D screen. He can able to rotate it, he can able to zoom in, zoom out. This is a kind of one pump as a product. So now he wants to see the particular pump in his own space, wherever he want to fix it. So he can click one button in the browser. So automatically the camera will open. He can place the pump in wherever he want to keep it, whether it's maybe a floor or maybe any flat surface, he can able to fix it. And the zoom in, zoom out, we can allow it. Or if you want to fix the scale one size also, we can fix it. So he can see everything. Then he can decide it. In few seconds, it will be loading in his floor or table, wherever he wants it. Maybe it's Android mobile phone or Apple, both are possible. So suppose if we have 10 products or 15, any kind of product, we can convert as a AR-based one, and we can embed in our web page itself. So all our users can experience it before they buy it. So next is a VR-based virtual.
One question.
Yes,
what
sir.
you showed.
Okay.
Is there an augmenting in this, or purely it's VR only?
This is augmented one. So as I said, this is a web AR, sir. So web-based augmented reality for any product. So now, as an example, is
true, but the real environment is not there, no, to superimpose. You're simply doing only in the virtual environment.
No, the video. So this is in the screen itself. The user can rotate and he can zoom in, zoom out. So that is the one thing in the screen itself. And augmented is after clicking the button, the camera is open. It is a granite floor you can able to see. This example. So that is the real.
What you're saying, that floor is a real floor, is it?
That's a real floor actually. That is a real floor actually. This is a screen recorded
got
one.
It.
This is actually his. It is recorded in a floor actually.
Understood. So you do it on a real floor. Okay.
This is a real floor, sir. So you can able to augment it. Yes. So now you can see in online, I think many furniture websites already having. So if you want to buy any sofa, you can in mobile itself, you can place in your home. You can see that whether the color and size and the fabric, if it is okay or not, you can swap many models.
So you are superimposing to the real environment.
Yeah, real world.
You are superimposing the picture on a physical environment. Okay.
There's 3D models. And it can be interactive also. When the user can touch it and he can able to see the specifications, it can open, you can see the cut model. So whatever he want, we can give. Exploded view also we can give. So whatever the way you want, we can give.
Thank you.
The interactions can be done. Yeah. So it's very simple one, sir. In the browser, all the browser we can have it. So the user can see and he can experience it and they can buy it. So then another one is a small one. During the Corona time also we have done that one. These kind of samples. Very simple one. So normally we saw virtual reality or augmented reality. We need 3D model first. But augmented reality, we need less model. Only the particular model only is needed. Remaining is the real world. But virtual reality, we need to develop the entire world as a virtual world. Suppose if we have a lab, if you have a factory, so we can have a 3D or 360-degree camera. We can shoot it. And we can make that as a 3D model. Inside that, our customers can walk through. Like a virtual factory tour can be done. Virtual factory lab can be done. A virtual, the university or virtual campus walkthrough. All these things can be done. So some sample we can see. This is also a very simple one. Only thing we need
sorry to interrupt. That particular complete 3D model of the environment, is it almost like a digital twin?
Yeah, we can say that digital twin, yes, slightly. Yeah. Suppose if we can able to embed live data also, it's a digital twin. Also, it may be a fixed one also. Suppose if it is a virtual showroom, you can see one Blue Star showroom in the first picture. It is a kind of fixed one. So the user can walk through into the showroom. He can select any model. He can get all the specifications and details. He can understand that that is one. Suppose if it is a lab or any factory, if we can able to integrate the live data, then it is a kind of digital twin. You can walk through that and you can able to see the live data. So at the moment, how the real factory
I
is
see.
happening, you can do
So
that.
that is the real difference between, that is the difference between AR and digital twin. Got it.
Yeah. Digital twin is only whatever is physically happening. Now we can able to remotely we can able to see the same in the virtual one, but in different format.
Thank you.
Yeah,
Thank
that
you.
is the basic digital twin, sir. And this is a very simple one. I can show one kind of one factory, one chocolate factory. It will open in the browser. It's already available. So normally we will use the the 360-day camera. We can use it. The Matterport is very good camera, and we have used it even for Maxbyte. Our office also we have done like this. So we can shoot it and we can make that as a model. So this is a built area. We don't need to create this as a 3D model. So this is a kind of chocolate factory. So I can build it. So the user can walk through here. So yeah. So if we place it, so whatever we are tagging, lively we can see that. So now it is readily available. Any video or any picture, we can see. The user can see that. See, I can play this.
Hi everyone, I'm Jael Radigan.
So this is already recorded one. So this is not live.
We're here today at French Broad
But it is
Chocolate
this way,
Factory.
any
This
virtual
is where
factory
all
tour
begins
can be
for
done.
our company. We import cacao
Virtual
from
campus
our
visit,
farmer and producer
virtual
partners.
resorts
We
walkthrough,
transform it into
anything can be done.
cacao.
So we can tag like that. So we can just, with the camera, we can shoot with the multiple locations. We call it as active points. Multiple flows also can be done like that. You can just walk through. Suppose if you have a VR headset, you can use the VR heads and you can walk through that. See, and you can tag anything. Suppose if you can able to tag live data, any live temperature or a live any specifications, then it is a kind of digital twin. Because it is static. When we take the picture as a 3D picture, whatever we took particular day, particular lighting, that is a static. But the data we are tagging can be a live one. So now it is a fixed.
So,
yeah.
right now what you're saying is passive. When you do the live, it becomes active.
Whatever we are tagging, we can give the live data. So at that time, the data will come from the cloud. So now it is only the video that is already recorded one. So
Very
like
good,
this,
very good
very simple one, sir. Even campus, multi-story building. For if it is not confidential, we can allow our user or customers to access it. This kind of virtual tours.
Got it.
Yeah, this one of the applications. Just time. Yeah, now I will come to the presentation again. Yeah. So another two examples also there. So in Maxbyte also we have done it. Very simple one because this is done with our Apple camera itself. See, you can see Maxbyte. You can walk through like that. This is now we are doing in the browser. Suppose if we have a virtual reality headset also, we can use it. So like that, any facility can be recorded like this, sir. Just I'm showing example. It's one of the simple example for VR, how VR can be used in the browser also for our customers. So next, another example for the design side, the prototyping. So VR-based prototyping will reduce the time and cost. So instead of developing a physical prototyping, so quickly we can develop the AR-based 3D model-based prototyping, and we can fit with the actual space where we need to replace with that particular model. And our customers can also remotely, they can able to review it, they can able to validate it. So if you want to change the model or change the design, very quickly we can do it. So this will reduce the time of creating the physical prototyping, and we can validate it also. This is one of the design phase application. And coming to the operation side, the AR-based work instructions is one of the very simple and very effectively used one. Suppose we can use a mobile also or a tab also. It is okay for this AR-based work instruction. Work instruction means step-by-step instruction. A person who may not know all the steps, they can simply follow the steps and they can accomplish the particular task. That may be an assembly, that may be any SOP, that may be a maintenance work. So we can record anything as AR-based application, and we can give to the mobile or tablet or mixed reality glass also, and he can do that. This is one of the sample we developed. This is a tablet based one. So this is kind of maintenance work. For example, there are a lot of fire pumps are there. For each and every fire pump, many maintenance tasks are there. So now we can see some sample. So this is the one sample task is there. So the person who may not know the particular task in detail, so he can able to select the task and he will get all the visual guidance before he he does the task. So this is the real world. In that one, he could be able to keep the particular model, and he can get all the step-by-step guidance. He can choose what are the prerequisites,
Prerequisites. 1.
safety instructions.
Before starting work on the pump set, make sure it is disconnected from the mains and cannot be switched on accidentally.
And
2. During dismantling, the various valves in the
and in the right side menu, he can able to scroll it. He can learn steps one by one. He can visually he will get the guidance, and also will get the text message, and also will get the audio. So all these three could be able to ensure the just-in-time learning, so that he can complete that particular task without anybody's guidance. This is with the mobile itself.
2.
So
drain the pump by opening the drain plug and the air vent screw.
The graphical guidance also will be there, where it is to be done and how it is to be done, and what tools it is to be used. So all these things we can give visually.
Step 3. Disconnect and be taken away completely.
So like this, in this one, many number of tasks can be recorded like that. This is one step-by-step instruction for the particular maintenance of the pump. So likewise, any kind of thing we can make it as application. We can give even 100 our assembly engineers or service engineers. It can be scaled to any numbers. So so that without asking anyone, they can select the task, they can learn it, they can do it. So that is the one of the AI-based work instruction application. So next is similarly same kind of work instruction. I put it as operations. So this is a hands-free. Only thing, the device cost is expensive. We can use the HoloLens, Microsoft HoloLens as a mixed reality class. Here also he will get the similar, the holographic guidance and audio guidance and the image and text he will see. It will guide him, and without anybody's help, he can complete all the tasks. Even the person is new, whatever is already recorded in the application, he can do all the work without anybody's support. You can see the sample here. So in this mixed reality class, advantages is a hands-free. The previous one, it is you have to hold the tablet or mobile, and here the hands are free. But in front of you, wherever the the holographic support is anchored, the animation is anchored, you will see that all the text guidance and visual guidance, image guidance, animation guidance, you will get it, and you have to do each and every step one by one, so that you can complete any complicated task. Even any cabling kind of task also can be done. So this is the real-time application. So learning and applying simultaneously. So this is also AR, but the device is different. So instead of using a mobile, we are using the mixed reality class. So in this device, any number of programs can be stored like this. If you select particular task, it will guide one by one. So geographically, wherever we are locating, exactly in that location, it will guide. So there are so many SDKs are there. We can use it so that area targeting and spatial targeting we can use effectively, and geo targeting. So many anchoring methods are there, so that the person will get very clear guidance without any location change and all. Because in the XYZ coordinates, exactly it will come every time repeatedly. Another one, you know that many user manual is there, even for two-wheeler, four-wheeler, any machines we have it. It's kind of a printed book is there. Now we have a PDF file is there. Now with another next generation, we can use a AR-based user manual. This is one simple demo application we have done it. For example, one desktop milling machine is there. The user is buying that. But anytime, whenever he has any questions, so he can able to just open the mobile phone, and he can be able to understand that how the features, how the specifications are there, how the functions can be done, and he can understand that. So that kind of user model, you can do it. So this is one of the simple one. And in this example, I'll show that. So again, he is placing the 3D model of the desktop mill actually. But in the because as we don't have the the milling machine, we have done like a 3D model, but practically we will have a 3D real model, and in that we can able to augment all the specifications that may be text instruction or video or audio. All things can be augmented. But in this example, you see the model also 3D one, but all the tags also can be attached with that. So that all the standard features you can able to understand that now it is showing what are the standard features. You can choose any feature, so he will get image or text message, and also he can, when he touch the audio file, it will explain it. So entire the existing PDF file has been transformed as a AR based user manual, and videos also can be embedded. So on the particular machine, instead of taking a book or a PDF file, once with the mobile or tablet itself, we can able to get all the features like that. This is one sample only, but it can add very different methods also. When you touch it, automatically it will play audio also. Interactively, you can listen also. Okay, so this is another way of AR-based user manual. And again, as Sir already told, suppose if the factory is already enabled with IoT, already you have all the data of the machines and the production data, everything you have, maintenance data. So now, instead of seeing only in the monitors or TVs, suppose if you have AR-based devices, then you can have AR IoT integrated solution. So data is already available. Suppose if you have a tablet or if you wear a Microsoft HoloLens, you can able to see all the customized data with the very visual distinguished method to take to see the quick insight, to take quick decisions on top of each and every mission, just like how we are seeing cricket scoreboard, football scoreboard like that. So quickly on space you can able to see that. Suppose if we have a you can see one sample here. So this is actually we have developed it one sample. I will show that. For example, this is the BOPT. Assume that this is a machine. In that machine, one QR code is there. The supervisor, just if he scan with the mobile, automatically, immediately about the particular machine, all the current status, live status will come, and history also will come on the particular shift or particular week, how it has run, and what are the. Now it is a BOPT. It's a battery operated pallet truck. So the battery level and all the live data comes from the cloud. So without asking anyone, so likewise, we can embed these kind of customized dashboards on top of all the machines. So the data also not fixed one, this is a live data. So how the AR and IoT can be integrated. So now we are using a tablet or mobile, and suppose if you use a HoloLens, just he can walk through into the floor, he can see all the data, live data. He only can see that. So based on the indications, color indications, you can see whether it is running or not, or whether what kind of problem it has, how many production has been done. All these things quickly you can understand. You can take decision accordingly. And another one application, AR-based real-time monitoring. So for this, we will be using area-based scanning or spatial scanning like that. So here one example we can see how
Okay, here we are.
So here the piping and some the water flow is happening. So we have data, but instead of through the AR, it will scan the entire area and it will superimpose it, and lively you can see the fluid flow or the water flow and the flow direction and flow rate and its velocity and its pressure. All this information you can able to see exactly in that location. So once it is after the scanning, automatically it will superimpose, and the animation also will happen. So based on the color indication, you can understand all the details.
Inlet pipes running down. See, running behind these pipes. and into heat exchanger. The green one then shows the flow out through the condenser circuit. They flow back through the condenser toggle boiler. Similarly with the
So this is called as real-time monitoring. And another one example is the real-time condition monitoring. This is slightly different. Actually, we have done it for genetics. And normally this, this is a modular manufacturing system, MMS machine. And so this is, being used for learning purpose. And suppose if it is there in lab and it is being operated, and this each and every model, what is the current state is there. So remotely, other people can also understand that. So see that. So that is a kind of application. Yeah, I will show that. Yeah. So now, in the lab, the MMS machine is there. It is being operated. Now I am, standing in some other location. If I want to know the current status of the particular machine, I can just, load the particular machine in the floor, and all the live data can be seen in the floor. So apart from that, what you are seeing is a help actually. There's a video-based help and PDF-based help is there. So when we click the I button, it will open and it will explain you how it works, how the functions are, the functionalities, then all these things. Apart from that, the live data. So now what you are seeing, the pressure and everything, the product position and everything you are able to see here. So if it is connected to the IoT from the cloud, we can see the live data also. And when we click the I button, each and every module, how it works. So that also will explain. As a PDF file, as a video file, all this can be embedded in that. So this is for the students, it is developed actually. And another one, for the operation side, as I said, virtual reality is very effective for the training. Suppose for any CNC machines operator training or any bigger earth mover training, if it is very expensive, if the training, if we can able to take the the training to the location, it may be hazardous or it may be very expensive. Then we can create that as a digital one, and we can allow him to play in that, to learn many times. He can make any number of mistakes and he can learn very well. Then we can take him to the particular machine finally. So that way, one small example you can see how the VR can help to learn a CNC machine operation training.
Step 1. Turn left and turn on the electric main switch.
So these are some sample steps. So after wearing the
Step
VR
2.
headset,
Turn on the servo
he will get all
voltage
the guidance,
stabilizer.
and he has
Press
to
the
do each and
green
every
button.
one
Auto.
by one.
Step 3.
So now
On
the hand,
power
what you are
knob at
seeing
the
is actually a
backside of
person is
CNC
doing actually.
Machine. Step 4.
Once if you do one
Press
particular task
CNC
only,
on
the next
button
step it
on
will go.
control panel and
Now it is
rotate
recorded one.
emergency stop button when alert message will come up. Step 5. Pick the raw material and place inside CNC and close the door. Step 6. Press reference button and press X and Z button. Click offset button and click program button. Finally click cycle start button. You are done.
So this is one sample, how just 10 to 15 steps, how we can able to, so any number of steps he can create like that. And he can do wrong also, so that he can redo the particular steps again and again, so that the person can learn it to operate the particular machine. That may be a very expensive machine or hazardous one. So you can learn it, and then you can evaluate whether he has learned it or not. Then we can allow him to the particular real-time operation. So that kind of VR-based training is very effective. Next is a VR-based safety training. So this also we have developed some modules like that. So normally the drill can be done physically. Apart from that, all the classroom trainings can be converted as a VR-based training. So each and every individual can wear the ear headset, and 1 hour we can allot him. So he can learn all the modules, and each and every module he will learn each and every many learnings. So that during the this kind of emergency time, he can able to operate the extinguishers, everything. He can learn everything through the VR based one. So that is one example you can see here. So the learning that can be developed by any different way. So he will learn first the theory, and he will learn then through the MCQ question whether he has understood or not. So that he has to pass. Then he will allow simulator real time, that the situation, and we can allow him to implement the learning learned one, how he is in the extinguishing the fire through the with the extinguisher, and whether he is following all the the safety instructions and everything. So that way each and every learning has been done. You can see some sample here. So first, actually, he has to understand how to operate the controllers. That may take few minutes. Then, if it is familiar with that, then he can go into that VR-based learning. So here is there are for the safety training, there are many modules are there. Each and every module, many learnings are there. He's just choosing the module and he's completing each and one by one. Now all the task. So for each and every task, first he has to understand the theory. Through for the theory, you can see video, pictures, or the 3D models. You can understand that how the extinguishers will be there, types of extinguisher. All these things he's learning here now. So that also interactively is learning. With the many examples, you can understand how what is race means, and visually is learning.
From side to side.
And he can able to operate that one also through the on the controller. It will be a simulated one, so you can understand how to operate the extinguisher. So after the learning is tested through the MCQs. He has to choose all the one, so he has to pause it. Then he is allowed to the particular the real time situation. That's also the virtual one. Yeah, now the real time world. So he has to implement it here. So quickly he has to follow all the learned the steps in the particular learning.
Pick the phone to call. Emergency number. Take extinguisher and extinguish the fire.
Cease operations and leave the building utilizing the nearest exit or fire exit stairway. Do not use elevators. Repeat, do not use elevators.
Touch the door handle to exit. Appreciated you have put off the fire.
So this is a one learning, one in the particular module, and there are many tasks are there, but only one task. So like that, many tasks are there. If we complete all the tasks, you can complete the particular safety training is done. So like that, the training, entire training, or any industry specific training also can be created like this kind of VR based learning. And another one example, as I said, how AR can be integrated with the IoT solution. VR also can be integrated. Sarah already told, in the browser itself we can do it, because we are integrated, because IoT data is already available, but the plant head or the management person is maybe in another country or another location, but he want to walk through the plant now virtually, he can do it. So this is we developed for one long back, a small one, a simple application. For example, many plants are there. The CEO can choose any plant from the browser, from the laptop, and he can able to see go into the particular plant, because the entire plant is as a 3D model. So kind of bird's eye view, you can able to walk through the plant. You can select any bay or any particular department, and you can get what is the current status of the particular department or a particular shop floor. Because the data is already available, but whatever the insights you want to see, you can able to see that. There's overall OEE, or how many production is there, how much and the quality data, and each and every bay overall working, how many machines are working. So whatever the production data, whatever the way he wants to see, we can develop like this. So this is the browser-based application. The laptop itself, he can just have a walkthrough experience. You can see the live data. But the 3D model is slightly primitive in this example. Maybe we can have a very good realistic model also. So in similar one, suppose if we don't have the model, as already we discussed, we can have a 360-degree camera shoot the shop floor, and we can embed all these things. So you can have a walkthrough in that. So this is a VR and IoT integrated one. And another one example, how AR-based warehouse management can be done. So here you can see if the warehouse engineer, if he wear any kind of HoloLens, he can make all the
Welcome. The time is 6:47 a.m.
so all the work very effectively, because he can able to get all the data. So all the visual guidance also to pick all the from the inventory where he has to pick each and every product. He can go directly to the location and he can pick it and he can complete the task very quickly.
Show item 1.
The size for item 1 is 30 by 25 by 5 and the weight of 0.5 kilogram. It's non-fragile.
So it will reduce his searching time and he will get all the insights, the current inventory data, current production line data.
2 okay. Okay.
Pick request. Proceed to maintenance area.
Okay.
And here in this use case, you can able to see it shows the battery indication also. So he is taking the vehicle to the charging one, so that it increases the uptime.
11.9.
Just put both tubes together.
Warning. Forklift nearby.
So this is a very good application how AR can be effectively used in warehouse management also. And this is another one we have done for our marine engine company to service marine engine. So there are so many service tasks are there. So all the tasks can be converted as a AR based one. But already we have seen how this kind of work instruction can be given through tablet or mobile. So this is the way you can choose particular task and you can get all the because in this one we have done all the models, QR code model and model targeting and spatial targeting, all the three it is available. So for particular task he will get all the guidance. I think it's similar to the earlier one we have seen, but the application is different. They will get the exploded view and service bill of materials, everything they can able to see here. Okay, so another one small application is a do-it-yourself application. So instead of just like the user manual for only for the troubleshooting information, we can give it as a AR-based application. So like this here, this is a BOPT. In the BOPT, suppose the user they have any abnormality, instead of contacting the service person, they themselves can see the service task, some troubleshooting task. So whatever the abnormality is seeing, he can select the particular troubleshoot task. He will get all the guidance what he has to do. So he has each and every step he will get the guidance and he can do by himself. So without if it is a major issue, you can contact the company or contact the service team. So now for any small kind of abnormality or service troubleshooting can be done by himself. So that kind of task can be converted as a AR-based application. And another one, VR for training, safety training, service training. So safety training already we have seen. AR-based service training we have seen. Similarly, VR-based service training also can be done. So we can use VR and the similar example, the pump service. So you can choose the pump type and specific task, and here he can do the service with the controller. He has to take the specific tool and he has to perform each and every activity.
Drain the pump.
The AR one, what we saw there is he will see, he will learn, and he has to implement it. Here, interactively he can do it. In this training, is completely virtual
Stuffing
one,
boxes
but
flushing
interactively
pipes.
he can handle the tools,
Disconnect
appropriate
them.
tools,
Stuffing
and he
boxes
has to
flushing
perform each and
pipes.
every the task virtually.
Straight up to prevent
So this is
damage
slightly
with
different,
thermal
and
parts.
certain trainings we can do virtually like this also. Yeah, we saw another
Step
one,
6.
CNC
Step
operator
7.
training. This is also similar
Step
one,
8.
but this application is different.
Release
This is for
coupling pins
service or
and
maintenance one.
pushes from half coupling.
Yeah. So another one, digital twin. So it's the digital twin. Normally we know this is a kind of concept. Whatever the physical location and the machine or a vehicle, whatever is happening, but we may be sitting in another location, but in front of our application. So the virtually we can able to see exactly the live or the graphical representation with the data. For example, the windmill, there are many windmills are there. Suppose in your application, if it is completely connected with the sensors and all the IoT devices, everything, so you can able to see, the live data. Then you can have a analysis and everything there. And if even inside the gearbox and based on the sensors, you can be able to see all the live data and any abnormalities there, you can be able to get the indications. So because without going inside the particular windmill, by sitting in a room itself, we can able to see, watch, we can see all the abnormalities. We can do analysis based on that, and we can predict also later. With that data, we can have the predictive maintenance also can be done with that, through this digital twin. And you can see another example here. The physically the particular ship is being loaded with all the goods, and virtually the person can monitor that. Exactly, he can able to see whatever the things is happening, and he can able to see the animated one in the virtual domain. That may be a VR based device also you can see, or any laptop or tablet also you can able to see. So this will really help to get a lot for analysis and for continuous improvement, so that they can able to optimize the process, optimize the loading time, or optimize, and they can able to predict that particular component failure, or improve the efficiency. So many things when we connect the physical and virtual world, the AI based applications, we can get a lot of insights and improvements can be done. These kind of digital twin applications. Okay, so another one, as Sar said, during the Corona time, it was very effective. It's a AI-based remote expert assistance. Suppose a machine is having any failure or anything like that, but the expert is in another country or another location. He has to travel, and he has to come, and he has to do the restoration work. Instead of that, we can wear the HoloLens or the mixed reality glass, so we can connect the other person.
Hey there, this is Andrew.
Hey Andrew,
how are we doing today?
So this
Hey,
is
how
just like
you
a
set?
Microsoft team. He can connect 5 person in 5 different locations in the world. So they don't need to have any AR device. They can join with their tablet or with their laptop or their desktop machine, and they can able to see what the person is seeing, and they can able to give guidance through PDF file or image or video, or also they can able to do the 3D annotation also. So we can see in this example here.
And even though I pulled it out, it's still not letting the machine start.
Okay, I think we'll be able to help you with this. We've seen it before. I'm going to start off by sharing a document.
So the expert is joining from another
Okay.
location. He's talking to him,
In terms of
and in the HoloLens there are many cameras, and he can able to see what he is seeing here,
coming over right now,
and he can give the guidance.
Okay, great. Awesome.
But I have run into this before with other texts, and we've been able to mitigate it pretty quickly. But here you see you'll have the document for future reference.
And the expert can share
Okay,
any
great.
document to him, any PDF or any
Right,
image or any 3D file. He can explain to him,
You're going to
just kicked
and
on.
now if you pay attention to this,
and he can annotate
So
also.
it's in the process of charging up, but it looks like
So
it's
what
at
he has to
60.
do, he can give 3D annotation
Yep.
also.
So we should be good
Excellent.
now.
So now if we go back up to the Sonotech,
Okay.
great. We're going to want to make sure that initial knob's pressed in.
The emergency stop? Yeah, it's been reset.
Excellent. Now if you can pay attention to the reset button right here on this LCD screen. You're gonna press that button.
Oh, so it's a touch screen. I missed that. That's probably okay.
Beautiful.
Cool.
And you know, I
So
can see
5
here
people can
that
join,
you are at the right
and all they
operating
can see
temperature.
what
You
he is
wanna be at
doing
180 degrees or
remotely,
above.
and they can give their guidance to him.
Excellent.
All right.
So if you look over to the right of the machine, you're going to see 2 valves clockwise. Now, if you look down at the base ones I know you're familiar with, one here, one here, we're going to go ahead and articulate those.
Okay.
Excellent.
Oh, awesome.
So any complex task,
we'll help you out.
even like a
Bye-bye.
complex cabling task also can be done like this. The expert can be in any location, but remotely he can join and he can help him through voice and anything, and he can able to see how he is doing also remotely. So that based on that he can complete the task. So that the uptime can be increased. We don't need to wait for the travel. So travel expense also reduced, the time also reduced. So anyone and the person who may not know the particular task also, he can connect with the experts and he can do the task. And another one AR-based application is indoor navigation. For any facility or any industry or any multi-story building. So for any visitors, we can develop a application like this so that indoor navigation can be done. He can wear the HoloLens and he can walk and he can understand what's really happening around that area. So that kind of navigation help also we can give. Here we'll see a small example. This is a kind of small office. So the person who is coming newly to the office, he can able to see what all the departments are there, and he can able to understand each and every department what they do. Without asking anyone, we can do that. So any lab or any bigger facility, if there is no person to explain, then the visitor can wear the HoloLens. He himself can understand that. He can walk through the real space and he can able to understand that. Even for very bigger building, very big facility like resorts, so we can any bigger institution, we can do like this. So now the example is very smaller one. So without asking anyone, he will get all the visual guidance to go to any particular room or location. He can able to do that. Yeah, so these are all the examples now we have seen in this the product life cycle so far. How AR is being used, how VR is being used, how the mixed reality can be used in marketing or design, operations, and services like that. So when we use this application with the appropriate device, definitely the particular operation or particular task really, it will give more productive results. It will reduce time, it will reduce cost, and more better customer experience. It will improve the brand value. All these things happening. Coming to the operations, definitely you can see a lot of especially in the area of training, especially in the area of the operations. They don't need to wait for any experts or any service person from other side. So the productivity is really improving, and training time more than 50% that will reduce. And because of the VR-based trainings, the effectiveness also really high. The knowledge retention is really high, so that the operational cost will reduce it, and it will reduce the downtime of the machines also. So it will increase the uptime. And coming to the service, as we see that because of these kind of applications, it improves the first time rates, and each and every service, every maintenance, they can do perfectly they can follow all the steps without any failure. They will ensure all the safety instructions or the prerequisites. They can ensure it. They can complete entire task without any asking anyone. So that kind of thing can be done. And our customers also, we can give the user manual, do-it-yourself application. So all these things. And remotely, they can see live monitoring, that kind of thing also. That will really enhance the experience and give more value to the the internal departments or factories like that. So many value proposition you have listed. Yeah, if you have so far we have seen what is AR, what is VR, what is MR, what are the development processes, what are the devices can be used for AR and VR, and how VR can be effectively used in the trainings or workforce development, and various real-time applications can be done in design, operations, and service and marketing area, and how the benefits or value proposition can be achieved in that one. So now, yeah, we can discuss for any questions.
Wonderful, wonderful. One of the best AR course I attended so far.
Thank you, sir.
It is so comprehensive, and I can't do justice in 1 hour with so much of information. And now open to question. There may be many questions. I still see 36 people on the call. We started with 48. Being Monday, I think people would have gone. Mithun, Roopa, you can open it for the audio individually. Mithun is asking a question. Mithun? Bhavesh is asking a question. Can we open the audio to them?
Sir, I'm doing, sir.
Or can Selvin read the question and answer?
Yeah, I think I read a question in the chat.
Go ahead, Selvin.
Yes, sir. Mithun have one question. If we want to adopt some points, what data we should be ready with? Yeah. So first we have to identify where we need to use it, or where the process is really complex, where we need visual support, or where we need to reduce the dependency. So then we can plan whether we can go for AR or VR. So that kind of consultancy we can give. Then whether we can go with the mobile or tablet-based device is sufficient for that user, or they need HoloLens kind of thing like that, or they need browser-based application. So first we need to decide where we have any complexity in transferring data or getting insights, time delay in insights, so many things. So then we can plan and we can implement it. Suppose if you already data like any format, maybe IoT or any other SAP data, whatever it is, also we can integrate with that so that the user can get quick insights with a customized format. So that we can do that. So based on the requirement, we can study and we can suggest you. So this is the device, this is the technology you have to use it. So this kind of application is really needed. So we can give some suggestion for that. And
thank you, sir.
Selvin, can I ask you one question?
Yes, sir.
Thank you, sir. It's okay.
No,
We'll
why
anyway contact separately.
Yeah,
Thank
why
you.
it is called augmented reality?
Yeah, so the initial slides I have explained that. So the augmented reality means basically we could see the real world. So normally through our eyes we can able to see the real world, but in the augmented
that is
reality
the case
also,
with the virtual reality also, no?
Virtual reality you cannot see the real world. So even if you see the device itself, it will close your eyes. You will see completely 3D, world. You might have experienced, in mall and all on the 3D or 5D experience, something like that. You will see completely 360 degree. When you can see all the three around yourself. You can able to see the new the digital world.
No, as the word meaning starts. Augmented means addition. In addition to the reality.
Real world. Augment.
Okay. So what is that augmentation which you are bringing in?
Okay, it's a matter of English. Can I take this call?
Yeah, please.
Chandramouli
is up.
Sir, you are augmenting the virtual. Virtual is a digital world. You are augmenting the virtual world with the real world. It's not the other way around. Or you can even say, I'm augmenting the real world with the virtual world. In other words, suppose you are repairing a compressor in a remote place. You need the actual compressor. The augmented reality engineer will be looking at the actual compressor, not a digital compressor.
Okay.
And then he will impose the training that he already underwent, or remote assistants will come to ask the right questions. Then he will repair the compressor. So the person in the augmented reality is standing in the real world. He is not standing in the virtual world. He is standing in the real world.
Okay. Thank you.
Whether if he is repairing a tractor, he must be standing in the farm.
Yeah,
if he is
I
repairing
got
the
it.
earth mover, he must be inside the mine. If he is repairing a compressor, he must be inside the factory.
No, without he himself reaching there, is getting the feeling of. Okay.
No. Augmented reality helpful only when the person implementing is in the real world.
Okay.
Yes.
Okay,
But
thank you.
He gets all his instructions. He gets his work instructions, what part to be changed, what is the bill of material. All data, digital data is thrown to him through either a tablet, in which case one hand is tied up, or through a HoloLens, which is worn in the eyes, where both the hands are free.
Okay.
A tablet is good enough to start with, because there have been a lot of complaints on wearing the HoloLens because it creates a dizziness, etc. So one of the bottlenecks of implementing AR has been the weight of that. It's a little heavy also to wear the glass, and also it causes some dizziness. First time users will not find it comfortable.
Okay.
But after a few days, only people feel it's like wearing a new spectacles.
Okay. Thank you.
Yeah, but we had question from Bhavesh and one more person. Bhavesh?
Yeah,
Yes, sir. Yes. I have written in the chat box also.
I will read it.
Okay. Otherwise, I can also tell.
Yeah, no problem. How do designers and developers approach user experience design for AR application? Yeah, so as I said that first we need to develop, design the platform. So normally the Unity 3D is being used. Apart from that, the SDK, we have to choose it. So based on our requirement and the application, whether we need to go, what kind of SDKs we need to use it. So like most of the use cases, we use the spatial targeting method. So like any floor or any flat surface, it has to detect. It has to load or it has to be anchored on that one. So that kind of SDK is mostly available and many free SDKs are there. Then suppose if I want to do any service in a bigger machine, I need all the instruction on top of that machine where I have to perform that particular maintenance service, everything. Then I need model targeting. So when I have the tablet or when I wear the HoloLens, it will scan it automatically in the camera. It will scan it. It will overlay it. Then it in the actual physical machine, it will only indicate it. So here you have to open the knob, or here the button should stop. Here it has to be done. It has to be cleaned. So only the indication will be coming on top of that actual model. So this target is different. This is a model targeting. It is really, it is a little bit expensive. So for that, we can go for V4 ER, very good one. So we have to choose these kind of SDKs first. Suppose if it is a very bigger one,
what is
we
SDK?
have to go for a software development kit. So software development kit, we need to pay for
software development kit. Okay.
Development kit. And many free also available. From Google it is available. Apple also it is there. And for spatial targeting, even before also it is free only. You can use it. Only for commercial only, we need to get license. So this one we have to decide for the development developer perspective. So that will implement, that will be the cost of the particular application. So if we have to choose the right targeting method, then he has to do the scripting one, and additional any images or 3D models, we need it because it's a completely visual one. So we need the model and everything, and the quality of the model also very important. Then he has to choose what kind of OS the device is there, whether Android-based device or iOS-based device. So we have to take the output accordingly. So these are all the developer's perspective major points.
So, sir, just I want to understand, can we import the ready-made 3D image in our software, which developers are using that AR application? Means, can they import ready-made? Yes.
Normally, because you may need many 3D models for the particular application. You need a machine or you need any tools, switch, whatever it is. Suppose you may have already that 3D models in AutoCAD or 3D model in CATIA or SolidWorks. If you have it, you can export it as a neutral format. You can use it. Only thing, additional texturing or rendering only you have to do it. So with some other editing software, you can do it. Otherwise, you have to prepare the 3D model also. So that will also add more cost. If you have already if you have 3D model, and many some general models already available freely also. Any tools, spanners, a drilling machine, that and all, and some websites are there. We can download it. It's freely available. Or any factory model also freely available. Some to create any environment. some freely available model also there, we can use it.
Okay. Thank you, sir.
Yeah.
Some more questions have come.
Sharan Kumar has mentioned one more question. I will read it. One of the best VR ARMR primers I have attended so far. Such an honest. Yeah, yes. Even appreciation. Yeah, thank you, Mr.
Complimenting.
And yeah.
Unknown user. I don't know. Unknown user questions we cannot take. Roopa, there must be a discipline that there must be names of people. Right? I don't know who's unknown user. SY, unknown user. I thought you have a rule to enter the name when people are okay. Sheshmani. What is the question, Sheshmani?
Yeah, I will read it. How BOPT differs with real-time monitoring. In the example, what I have shown is a battery-operated pallet truck, because that we have it in our test bed. So we on the live data of the BOPT also we have it in the Azure cloud, so that we have used that as a reference one. In that you might have seen one QR code was there in that one. So when the supervisor scan it, automatically the live data comes on top of that machine. So that may be a BOPT vehicle, or that may be a machine. But the thing is, when the supervisor scan the QR code on the particular machine, he will get the live stream data in AR. So that is the idea. From the cloud, the moment it will come immediately. But in the particular machine, there are hundreds of parameters. Normally we have it, but to take the decision, the colorful insights, we can have a small palette. We can create it, so supervisor can understand that what is the current level. They can understand that. So that, and if he has a HoloLens, it's simply the scanning will done by the camera. Automatically, the dashboard will pop up on top of that machine. So that is the example for AR and how AR can be integrated with the IoT. And the supervisor or plant head, they can able to see all the live data, whatever the way they want to take decision. So that was the example. We saw that. BOPT was just used as an example only.
What is BOPT?
BOPT is a battery-operated pallet truck.
Oh,
so that's one of the more product. So we used for that example at that time. So
understood.
There may be a machine also. Yeah.
Any other question?
Good afternoon, sir.
Yeah.
Sir, real-time monitoring is also like same that BOPT. Is it like same?
Yeah. Yeah, it's the same only, because instead of taking any machine, we took that BOPT as a machine. That is a vehicle, but in that vehicle was a connected vehicle. So in our test bed, we were having that BOPT. So that was connected actually. So how much battery level is there, and how many hours it has run, how many product tests we shifted, how long it has traveled. All those data we have it. So that is the reason we connected the BOPT as an example. The connected BOPT as an example for the how AR also can be a layer can be embedded on top of the IoT. So the user can easily, they can get the insights on top of that BOPT, because BOPT is a vehicle, it will run. We can stop it, we can scan it, and immediately you can understand the status of the BOPT. So that is an example only. So similarly, any number of machines in your soft floor, it can be connected, because it is already connected to the IoT. Suppose if we have one more layer AR, the person, maybe a plant head or supervisor, he can immediately understand the status. When we walk through into the shop floor, without asking anyone, he can understand the status of the machine and the productivity of the machine and any quality issues of the machine, and everything he can understand quickly, because the data is already available in the cloud. So that is the example I used the BOPT for AR IoT integration.
I have one question.
Yes, sir.
With so many benefits under marketing, under design, under production, under service, at least some 20-30 benefits you have shown.
Yes, sir. Value proposition.
But your adaptation of the AR, while the ROI is also good, your TCU also is good, but the adaptation is so low in your own graph. So what are the disadvantages? What are the disadvantages which are pulling down the adaptation? Even after 6 years of talking about AR from 2001 onwards, 2011. I'm sorry, 2020, from the COVID time. After 5 to 6 years, in the Indian market or even 10 years in the global market, why is the slow adaptation of the AR VR issues?
That also on status and on statistics I say, but I didn't put it in
broadly.
slide.
Just tell me the top
broadly,
three reasons. Top three
one-
reasons for slow adaptation.
Yes, sir. So one is the cost of the device. So cost of the device now it is getting reduced. Earlier, even VR headset is more than 1 lakh. Now it is Oculus is 50,000-60,000. It is available. It is coming down. HoloLens still it is 3.5 lakhs to 4 lakhs comes.
Why don't we talk about using only a tablet?
Yeah,
Forget
tablet
about
is
that.
yeah.
See, I don't want both the hands to be free.
Very
I
So
want one
tablet
hand is free.
Yeah, tablet-based applications, definitely the device cost is really less, but the application cost almost same. So when we use the Unity 3D, the licensed version with all the SDKs, suppose the cost also will be coming. And another one, the user experience is very, very important. Suppose the user can be able to access very quickly, very easily, then the visual application will be really useful to the user. So the content is very
happens
important.
only after he buys. I'm talking about why they are not adopting, why they are not buying.
The thing is, the cost of that, the application, still.
Point is, out of the total cost, the device cost is a significant one. If it is a HoloLens.
Yeah, the HoloLens side is.
Right. Forget about HoloLens. Let us talk about tablet or mobile phone. And there is a software application loaded on it or a web application loaded on it. In that context, why is adaptation should be slow? Because except after sale service where both the hands have to be free. When you are removing a bolt or a nut or whatever, the rest of even there, because India has got so many human beings, one person can be holding the tablet and another person can operate with both the hands free. He can still look at the tablet instructions and keep operating. There can be always one person who may not even be a talented person. He can just be a helper kind of thing holding that tablet. And still the maintenance operator can have both hands free. I'm still not convinced. What are the reasons for adaptation? See, everybody is adopting condition monitoring of the machine, productivity monitoring of the machine, OE monitoring of the machine, etc., etc. But AR being such a powerful in training as well as in service, as in marketing, as in operations, as in design, I'm not able to see the top three reasons why the adaptation is still very low, as you presented.
So majorly the application, even I saw one statistics thing is only the device cost and for the tablet is not there, and the application, the usability perspective, the content also very, very important, sir. The content is to get.
Sorry to interrupt you. See, you are a company implementing AR. You got whatever case studies you showed or your own case studies, right? They are not some hypothetical, they are not some YouTube download or something. So your company has enough experience to judge without statistics of the market as to why the adaptation is low. Anyway, if you don't have the answer to it, it's not a problem. Maybe your business managers may have the reasons. But the point is, there are some inherent bottlenecks. See, if everybody watches Netflix, everybody watches YouTube, 45% of the Indians have got a smartphone. All the Ola, Uber car people, drivers are not even educated for 8th standard, but still they use smartphone. Adaptation is fast when things are easy. You don't need an intellectual capability to adapt things. Whereas I find AR adaptation is low for some unknown reasons. I don't think it's due to the cost of the HoloLens because it also causes dizziness. So I will not recommend HoloLens to begin with because it causes a lot of dizziness. So even when I was wearing one day in a trial in some laboratory, I was a little bit dizzy, and all the literature talks about vomiting, nausea, dizziness, etc. But an ordinary tablet phone with that AR app loaded can be a brilliant methodology where the adaptation cannot be so low. Vuforia app is free of cost, you mentioned. Tablets are not very expensive, 10,000, 20,000, 30,000 rupees. Tablets are available. So somewhere there is an issue. Maybe you can address it in the next seminar.
Yes, actually, medical field they're doing really good, sir. The adoption is happening very well now. I've seen many
I know.
updates in that also.
You showed
Uh,
36% medical,
medical.
and that itself only 36%, 64% yet to go. But your overall adaptation is a very small bar graph.
Yeah. Still, the awareness also is needed because many people do not know that. That awareness also to be done. It's happening now.
In
And the e-commerce, it is happening.
In 5th year of introduction, awareness should be very deep.
Yes, sir.
So there is some issue with the budget. I think initial budget people are not willing to open the purse. No, is adaptation low only in third world country like India, or it is adaptation low in America also?
That is actually global adoption only, that statistics what
Exactly.
I showed.
So
Yeah.
even the cash-rich countries, 28 people are still listening. Even the cash-rich countries, adaptation is low. Even the people with very high per capita income, adaptation is low. So therefore, it really surprising to me. Now, if you know the root causes, we can overcome it. So therefore, there should be a research to do. What are the root causes? Right, sir. So if you have some 100 customers, successful customers will give you a positive feedback. But if you have done the POC with 1,000 customers, proof of concept, those 1,000 customers, if you do a survey globally, you can get a clear indication of the reason for low adoption. Because 100 customers are happy people. The happy customer is not going to give you a negative feedback. But the other 900 customers may know the reason why it is. Right, sir. So this is only my business-oriented question. Also, unless and until adaptation is high, the number of people who are entering these jobs, the people called augmented reality engineer, we got a job description also for this job. It's all documented. Unless and until the industry adopts it in a big way, there are no jobs called AR engineer. You can count with fingers. That is my concern. So both adoption and employment are interrelated. Right, sir?
It's keep on increasing actually. So that is, you could see.
I know. So we need what percentage of, the best way to assess is actual implementation divided by POC. And actual POC divided by inquiries. If total inquiries are 10,000 and 1,000 are doing prototype testing and 100 are actually placing the order for implementation, I think the blue star photograph what you showed are real example, correct?
Yes, sir.
So there are very Indian companies who adopted it beautifully. Even in the retail store, I think there is a retail store, correct? Blue Star retail store, I think.
Oh, yes, sir.
With the deep freezers and all. Fantastic. So it's possible. So there is an awareness issue, there is a ROI issue, there is a POC issue, the conversion of inquiry to order. Unless that happens, then why would more people get into the job role called augmented reality engineer? That is also a question from my side. But we are getting a lot of congratulatory messages, right?
Yes, sir.
And main point is, Roopa should note that next time onwards, people should register the name. They should not be unknown user kind of thing. They should register the name. Then only we'll know who all attended.
Yes, sir.
Right, sir. Right, sir. Is there no more questions? Roopa can give the closing remark along with Colonel Harish.
Thank you, sir. And thanks to Mr. Selvin. That was quite a exhaustive and knowledge sharing session. And thanks once again for the support from Maxbyte. And to all the registered participants, we have the next session on March 17th on autonomous industrial vehicles for greater productivity and cost savings. So please, we will be sharing the calendar invite and we request you to kindly make it convenient to participate in that session. And thanks, Mr. Selvin, once again. And we'll be sharing the link for the YouTube recording shortly. Thank you.
Thank you, ma'am. Thank you, sir. Thank you all.
Thank you, sir.
Thank you,
Thank you,
Roopa.
sir.
Thank you, Gift Selvin. Thank you, Mr. Colonel Harish.
Thank you, sir.
And thank you all the audience who attended and who registered. Very soon that will be uploaded in YouTube and then we will share with everybody. Thank you very much. I think there are a lot of vote of thanks have come, a few comments, and it's very heartening to see such a comprehensive session was attended by a lot of people. Thank you very much. Thank you, Gift Selvin. Thank you, Maxbyte.
Thank you, sir. Thank you all.
Bye-bye.